Okay, good morning students. Today we are going to see the one more two problems on Thevenin's theorem. So the problem statement is like this: find the current through RL using Thevenin's theorem. So the circuit diagram is 10 volts, 2 ohm, 1 ohm, 2 ohm, then here is 13 ohm, this is the RL, then here you have the one current source connected, this value is 10. So first we need to find the equivalent resistance. So for equivalent resistance I will make this current source as open circuit and this voltage source as short circuit, and the equivalent circuit I will get it as like this. So this is the equivalent circuit. So check these two resistors are in parallel. So 2 into 2 divided by 2 plus 2. So it will get it as 1 ohm. Then 1 ohm is in series with 1 ohm. So RTH will be 2 into 2 divided by 2 plus 2 plus 1 ohm. So it is 1 plus 1 equal to 2 ohm. So this is the equivalent resistance. Then we need to find the equivalent voltage. For that you have the current source here. This current source I will convert it into voltage source. So 10 into 2 is 20. 20 ohm is 20 volts in series with 2 ohm resistor. So that equivalent circuit is, here it is 2 ohm, here it is 1 ohm, then here is 2 ohm resistor in series with 20 ohm, 20 volts, then here it is 10. So it is 10, here it is 20 and 2. So we need to find the voltage across these 2 points A and B. So if you go for a node analysis, you can make this as reference node. This is the reference node. Here is V1 I will take. So we need to find the V1 that is across A and B. So it is V1 minus 10 divided by 2, then plus V1 minus 20 divided by 2 is equal to 0. So 2 into V1 is equal to 30. So V1 will be 15 volts. Okay. So then the equivalent circuit, what we get is, the equivalent circuit you are going to get it as this is RTH, this is 2 ohm, then this is VTH equal to 15 volts, then here is the resistance RL, this is 13 ohm. So what value you are going to get it is, here if I find the current I flowing through this is nothing but minus 15 plus 15 I is equal to 0. So I will be equal to 1 amperes. So this is the current flowing through 13 ohm resistor. So this is one problem. Then we will see one more problem, that is find Thevenin equivalent circuit between A and B. So circuit is like this. So voltage is 30 volts, then this is 5 ohm, here it is 25 ohm, here it is 60, here is 20, then the current source is 1.5. So you need to find it between A and B. Okay, so we know that first we will make the current source as open source, that is solution. So this is the open circuit, then this becomes the closed circuit. So when I close this and make it as open, it will be like this. It is like this. So we remains with only 40, 5, 25, 20 and 60 ohm resistance. So one more thing here, when I make it as short circuit voltage source, so this becomes the least resistance path. So the current takes the least resistance path, then we will omit these 5 and 25 ohm resistors for the calculation. So the equivalent circuit for RTH I will get only like this. Here it is 40, here below it is 20, then here it is 60, because of least resistance path. Okay, here is 40, 20 and 60. Okay, so next what we will get, these two resistors 40 and 20 are in series, so this becomes 60. So 60 is in parallel with 60, so the value I will get it as 60 into 60 divided by 120. So this you will get it as 30 ohms. So remember, here is least resistance path. Least resistance path. Okay. Then, so when coming to calculating VTH, for VTH calculation, okay, first you check the current source. Current source is in between two loops, so this becomes the super mesh. So I will consider this as the one complete super mesh. Okay, so now you write the constraint equation. So if you want to write the constraint equation, what we will get as, I will consider this as the X current, here it has Y current, then here it has Z current. Okay, so first equation, Y minus Z is equal to 1.5. This is equation number 1. Then second equation, what you will get here for X, if you want to write, what value you are going to get, minus, here it is minus 30 plus 25 plus 5, that is 30x, then minus 25y minus 5z. This is equal to 0. This you can take it as equation number 2. Okay, then write the equation for super mesh. So for super mesh, what you are going to get is minus 30x plus 105y, then plus 45z is equal to 0. This is equation number 3. So these equations you know how to write. So now we will get the x, and if you solve these 1, 2, 3, we are going to get the x, y and z value. So the value of x, y, z are x is equal to 1.5, comma y is equal to 0.75, comma z is equal to minus 0.75. So we want the voltage across 60 ohm resistor. So y into 60. So VTH will be what? Y into 60, that is 0.75 into 60 is equal to 45 volts. So we got this value. So they ask the Thevenin equivalent circuit. So Thevenin equivalent circuit is nothing but we want RTH and we want VTH. So it is VTH equal to 45 volts, RTH is equal to 30 ohms. So this is the Thevenin equivalent circuit across A and B. So these are the two problems you need to solve. So in next class we will take some problems on the dependent source, and we will continue further in the next class. Thank you.